Hello everyone. On behalf of Indian National Trust for Art and Cultural Heritage INTACH and the INTACH Conservation Institutes, I extend a very warm welcome to our distinguished speaker, Mohamed Ibrahim from Egypt, and everyone who has joined us for today's talk in the Conservation Insights 2020 lecture series. I'm Dr. Padma Roila, Director ICI Delhi. Now, to introduce our speaker, Mohamed Ibrahim is an archaeological conservator associated with the Egyptian Museum, Ministry of State of Antiquities Affairs, Cairo, Egypt, and he works on organic material such as wood, papyrus, and paper. He is also responsible for photographic documentation and investigation using multispectral imaging and RTI. He finished his licentiate in archaeological conservation from the Cairo University in 2008. He has been a conservator, a part of the team, a conservator as part of the team in the following projects: the Abydos excavation in Egypt, involving the conservation of two block-lifted human burials; the team from Cambridge University excavation mission in El Al-Marna, Egypt; the first aid for Roman mosaic floor, Ostia Antica, Rome, in Italy in 2018. He also conducts training and workshops and has a number of publications to his credit. The title of today's talk is RTI as an Effective Method for Cultural Heritage Investigation. This presentation will focus not only on RTI as an effective method for cultural heritage investigation to observe minor details unseen with the naked eye, but also as technology presenting several advantages such as being inexpensive and widely available hardware, ease of carrying out in the field or lab, with little equipment beyond that required for standard photography, and all the necessary software being freeware. A number of examples will be presented to illustrate how RTI can be applied in studying cultural heritage objects. Before I invite Mohamed Ibrahim, may I please request all of you to please mute your microphones. Please type in your name, email ID, and organization name in the chat box, and also type in your questions. We'll be taking those right at the end of the talk. Now I request Mohamed to please start with this presentation. Thank
Thank
you so
you.
much for doing this, Mohamed. Over to you now.
Thank you. Yes. Thank you for coming today. I want to thank Dr. Rohila for giving me this opportunity to participate this event. I'm looking forward to talking with you today about reflectance transformation imaging or RTI as an effective method for cultural heritage investigation. So, uh, sorry. Today, I would like to share with you some information about this non-invasive method of investigation. This method has many other advantages, make it widely used in cultural heritage field, and deserve wider appreciation and application within the discipline. This presentation will focus on key points. First one is what is RTI. The second one is how does RTI works. The third one is what is RTI used for. And last one is how is RTI applied. And finally, we will talk about some examples and at the end of this presentation and also through it. So first of all, as conservator, doesn't limit our role to preserving cultural heritage through direct intervention with restoration work only, but also to study and collect information about artifacts through investigation, through examination, through analysis, using non-destructive methods, which help in understanding the nature of the object itself for better protect and applying better restoration. Reflectance transformation imaging or RTI is one of these non-invasive methods widely used by experts in the field of archaeology, restoration, and historical science based on this method is based on the set of images with varying knowing light. So, our first key, we are talking about what is RTI, what is reflectance transformation imaging. This technique it's a computational photographic technique used to study surface morphology through imaging objects under different direction of illumination to create a composite image that make RTI an affordable and accessible resource, which would be beneficial for both cultural institutions and individual conservators for the introduction and evaluation of cultural heritage. So when we talk about the beginning of the RTI, or reflectance transformation imaging, it was invented by Thomas Bender and Daniel in 2001, and they published their work in a scientific article under the name of polynomial texture mapping, a new tool for examining the surface of painting. In that time, they were focusing on the surface texture and shape of paintings by using the raking light photograph made by casting light across the surface of painting at a very low angle, highlights any surface texture or morphology or irregularities. And RTI has many advantages. We can talk about this. It's in this slide. We say RTI as a technology presents several advantages. So it's inexpensive because we can and widely available hardware. In this photo, we can see that it's we can use just the camera, professional camera, the tripod, and light source, flash or something, and a roll. So everything is available. RTI also can be carried out both in field or on lab. And in this photo down here, we can see that they can apply it also underwater. So it's it's easy to apply it everywhere. Uh, with a little equipment beyond the required for standard photography. The third thing, it's all the necessary software is a freeware. So we use two software to generate and to view the reflectance transformation imaging by using RTI Builder and RTI Viewer. And both of the software is free. You can find it free on the Culture Heritage Imaging website. And I will put the name of this website at the end to everyone if you want to download this source. And also there's a lot of explanation about how to use it and the manual. Finally, we can apply it on large and small objects. That's why RTI deserves wider appreciation and application within the discipline. After talking about disadvantage, now we will talk about how does it work. So reflectance transformation imaging is a method of capturing how the surface of an object interacts with light. This process yields interactive visualization that allow users to manipulate the direction of virtual light source. So we were talking about the light. Light bounces of surfaces such that the incident angle of the light and the reflected angle of the light are equal angles to the surface. Since the camera is in fixed position, so we fix the camera, and we already know where is the light is coming from in each image, and because we sample from variety of light position, because we put the light on 15 degree and 45 degree and 60 degree, and sometimes we use 90 degree. So RTI software can calculate all this light position in from the surface and give us the picture, and we can control it to know the information. So in this slide, we can see the photos here, and every photo from these four photos, we can see that the light came from a different position. The first one Here we can see that the light came from 90 degree, from 60 degree from the right, and from 45 degree, and from 45 degree but from another position. So the mathematical description of the normal is saving the pixel. That's along with the RGB or red, green, blue, the color information of regular photograph. This ability record efficiently the color and the true 3D shape. The information in the source of RTI documentary art. So the next point is what is its use? RTI in particular has provided itself an valuable tool for conservators and artifact specialists. RTI can provide to pursue important tasks for investigation, documentation of state of conservation, and to study the technique that we use or the accepted technique of making any object. RTI has been employed for the virtual examination and study of cultural heritage artifacts. We can identification of manufacture technique. RTI helps has helped to discover textual features that are we can see by naked eye or through other inception technique, or that couldn't be properly recorded with written light photography. And in this photo, we can see the support lines, and we can also account how many pieces of wood was using for making this object. And we also see the details that the brush stroke, and how they make it, the layer of the object itself. In this slide, RTI provides to be multiple tool because it's combination of lighting manufacture, it's a combination of lighting, magnification, and rendering filters, served to discover size, location, and extent and the character of appearance damage. So in this photo, we can see here the damage that happened to this photo because we can see the surface, the support is moving and start to make buckling or shape of arc, and that makes some cracks, and we can see that there's some parts we can document the alterations that produce that change also from this method, and damage that could be better visualized on different surfaces included cracking on painting surface, cracking, bruises, surface deposit, scratches, holes, and even we can define the previous restoration work by using this method, this technique. And we can see here in this also, we can see the shrinkage and the breakage. So the next point is how to use RTI. There are two methods that can be used to implement the production of RTI. First one is the standard RTI, and the second one is the highlight RTI or HRTI method. Most of people use the second one because the first one we need to have a dome, or it can be achieved through the use of this dome, which consists of light-proof structure with a large number of plugs, each of which can be turned on individually to provide sufficient illumination to allow the fixed digital camera to allow the fixed digital camera suspense over the artifacts to take an image by taking a sequence of images using all the light the data required for processing is acquired. And not everyone has this device or this equipment. So most of us using the highlight RTI or HRTI that we were talking about this now. In this method, it's more flexible. We can be carried out in, as we say in lab or outside in the field, uh, but is particularly effective in the field. It's slower than the dome, but it's easy to use in the field. The equipment required is extremely portable and flexible, involving few items beyond those already expected in the field of photographic kit. And we will talk about this method in detail on the next slide. RTI equipment. So RTI equipment, first thing is a fixed camera to subject alignment. You must set the digital camera on a tripod or camera stand for stability. And to eliminate vibration during image capturing, we can put some sandbag or other weight can help you for further stabilize tripod and support. The recommended method is to connect the camera to the computer and use the computer to control it for testing your setup and when shooting the image. This way, you can trigger the camera and flash directly from the computer and download and name your images at the same time of capturing. The next set is the reflective spheres, at least two black reflective spheres, or sometimes we can use silver also, are placed near the subject in the camera field of view. Depending on the size and portability of the target object, you must compose the camera's field of view so it can encompass both the object and the two reflecting spheres. The third thing is a string. The string is attached to the light source to keep the distance of the light from the object must be the same for all shots. You can easily measure it with a string. The string is approximately 2 to 4 times the diagonal measurement of the object or object details you wish to image. And here is you can see the kit, all the equipment that need for RTI generate RTI code. So the most important thing about this technique was the light. So we must have a portable lighting unit of a type and intensity appropriate to the location and environmental conditions. So we use different units inside lab than in the field. So we said that the semi-arc at 15, 30, 45, and 60 degrees lighting angles was used to illuminate the surface of the object to reproduce the highlight point in the reflected target. The object was illuminated from the light position, moving the arm every 20 degrees, flowing a pattern with radial spokes, creating a virtual dome. That's because we don't have dome, so we have to move. We have the string and we have like this photo, we have the flash, and we start to move it like we can see here in the numbers. We can see one, two, three. So there is a shots, and you can see on the sphere, on the black sphere, the shots is. So this is the flash here, and you can see from this one the tripod legs. So this is a tripod leg, so we can shoot here, and we can shoot here, and we can shoot here. This number of shots give us the opportunity to generate the image. We not only can use just the visible light, but also RTI technique is able to complement not only visible light, but also UV, RTI or IR also, or infrared. So all these light techniques provide us with additional information on underpainting, or underdrawing, new and old repairs also can be defined by these techniques and their sequences in the technique also, and some texture information not otherwise available. The RTI infrared has a tremendous potential for fine art conservation and historical investigation. Sometimes we have in papyrus in ancient Egypt. Sometimes we found papyrus. It's unwritten, but when we make RTI, IR RTI by infrared, we discovered that it was written, but the carbonic ink is gone, but we still have the binding material, but we can't see it by our naked eye. But RTI can show us what even was written in this papyrus. Last thing is the computer. If you are using a computer to control the camera, it must be near enough to connect and be easily accessible. But it must be placed out of the way of the object and the camera also, and lighting area. We can mount it on any stable surface in order to field situation. It's useful to mount it on another tripod stabilized by weight or center. So this is the equipment that we use in RTI. Then the software, RTI softwares, we are using RTI Builder to generate the photo and RTI Viewer to make the interpretation for the photo. So this open source software has been adopted and developed by Capture Heritage Imaging Chi, and they have the software. They have the software on their website. So we will talking about RTI Builder. So RTI Builder, we use it first to generate the photo. So to generate this, we have two basic steps. We can go and make it generate the photo. So first thing is creating the project. When you invoke the RTI Builder, you create a named project and point the location of your image set. We can choose the processing sequence for the type of RTI files you want to create. It can be produced with the BTM or HSH. These two methods, they are the same, but BTM has more advanced filters. So both of types of RTI files can be viewed on RTI Viewer. After that, we start to find the light position by identifying the spheres. To do this, you must first identify the spheres uh, in one of the images and then turn the tool that detects the highlight and use them to calculate light position and generate a light position file. In the case of dome, or RTI dome, the first method, data capture and processing is different because each dome has a pre-built lighting position file. So there is no need to add sphere in this scene in data acquisition stage, but we have to use it in RTI highlights. The next step is to crop the image. The RTI should only the target the object. there is a tool to help you to crop the image so that the reflective spheres are not included inside the final RTI. The cropping tool automatically applies the same crop to entire image set. And the last step is to generate the RTI. The final tool processes the complete image set to produce the final RTI or BTM or RTI file. And at the end, we can find we have finalized that. Then we are talking about RTI Viewer. RTI Viewer is the software that allows us to load the uh, examine image created with reflectance transformation technique. This technique calculates both color and shape information from a set of images illuminated from different directions and stores that information in file. RTI Viewers offer RTI Viewer offers interactive rendering of image, allowing you to change the view and alter the appearance direction of light. In addition, it offers a number of enhancement modes, which apply mathematical transformation to the color and shape information to enhance or to increase particular feature of the target object. These transformations don't alter the original data, but can be saved separately so that they can be reapplied. We were talking now about an example. I will talk about Medungis. It's Egyptian, we call it Egyptian Mona Lisa. It's few years ago, uh, and I will talk about this painting. This Maidungis. The painting of the Maidungis was found in 1971 in the tomb chapel of Atik. She is the wife of the princess Nefert, who was the son of the first dynastic pharaoh Snefru. The latter is believed to have ruled Egypt for 54 years and built four pyramids uh, in the shore methods. One Italian archaeologist said his name is Travetti claimed that the geese shown in the painting were not known in Egypt in the same. He said it's an archaeologist from Italy. His name is Francesco Travetti, who has been excavated and restoring tomb TT 37 uh, in Luxor, told the publication that this painting, My Dungis, is a fake one, and so we have to investigate it and to be sure this is not just a wrong thing. It's original one. It's not fake. So he claims that the geese shown in this painting were not known in Egypt in this time, with one of them the being Greece goes being from northern Spain or Greece. We can count this goes in this area and Turkey. And the other, the red crested goes being from Asian coast of Greece and Turkey. Such geese were not known in ancient Egypt. Tarditi said. Tarditi said that Vasili was an artist and curator at the Bulak Museum in Cairo at this time. Based he should have looked. So we will say in two things: as a conservator, as archaeologist. So Dr. Zain Hawass said that he should have looked at the scenes of catching birds recently found in Sahur this way, and other recently found tomb in Saqqara by the Polish mission. These are the same kind of keys depicted in the same style shown in the medium in the Maidum painting. It's as if artists had imitated the Maidum keys in his work. We also have seen from tombs in Abu Sir and in Saqqara necropolis that show some 32 kinds of these keys. So this keys was left in Egypt at the time, but it's not. We didn't find it anymore in Egypt. The painting of my tomb keys was found on the northern wall of the tomb, and there is another two pieces. You can see these two pieces here. You can find it at the same wall. And as a conservator, we can use RTI to be sure this is not fake one, it's a real one. And we already make a research talking about this project, talking about this painting and how this person said a wrong explanation about that. So we start to make our research with our colleague Aid, who's attending this session also. So we use RTI, we use multispectral imaging, we use also XRF and many other investigation methods to be sure to this is a real one. So he said that it's fake one for only for this big, so the long one, the lease. But he said that the two other pieces is original. But when we start to use RTI to study the executive technique for the three pieces, the two pieces and the geese, my doom geese pieces, they came from the same tomb, so they have the same technique. We found that there's underlayer painting. As we know, as we know, the ancient Egyptian used the grid to make the scale for this drawing. So he thinks that he make it bigger, so then we make it smaller, turn it to smaller drawing, and we can see the all under layer drawing. It was big one, but it is small, so we can see it here and here and here. And he said this is two. One is this two. Pieces is original, and we find the same. We find the same because the ancient Egyptian artists also changed the scale of all these keys here also with the same technique. And we also using X-ray fluorescence to study the color because we also say the color is not using in the ancient Egyptian time, but when we make XRF X-ray fluorescence for all the color in this paintings, we found that all is the same. That makes it original, and we published all this research last year in the fifth Egyptologist conference here in Egypt, and we will publish all the results next year, inshallah, in a scientific journal. So here at the end, we can see here the references of my presentation. We can see here cultureheritageimaging.org. We can find explanation about it, and we can find a video about RTI, and we can also see the software RTI Builder and RTI Viewer. And thank you. I want to thank all of you for this presentation. If you have any questions.
Thank you very much, Mohammed, for that presentation. I think at this point, I don't. There's one question. Yes, with your permission, I'll take it up. It says, "Have you ever built an RTI dome with multiple light sources yourself? If so,
No, I didn't try it. We need to have someone expert on light, how the sequence of light is working.
Okay.
So it's very expensive to buy one, and it's very difficult to build your own dome.
Okay, but based on your experience, can you do you know that how many specific number of light sources are required in one dome, or is there any specific formula for placing these
So
sources?
if we
There
use
do it
yes, if we use four angles and we take three shots, so between the two legs of tripod we need 12 shots at least. So we will take at least 36 shots. So we need 36 light sources.
36.
Yes, at least.
Yeah, and positioned. Maybe the way you had mentioned in that diagram, one could position the lights in the same angle that you showed. The 36
Yes,
shots.
yes, we can see
Yeah.
here. Yes,
Okay. Yeah. So maybe the light sources, that diagram, the lights can be placed in those positions.
yes.
Okay. Thank you. The next question is, when you do RTI for papyrus, what possible things could be studied? How can RTI be applied to papyrus objects, and what possible findings could one find by using this technique? How do you
Yes.
apply this for papyrus objects?
It's the same for we use the same technique. We use highlights RTI. I prefer to work in dark area because we need to focus by the light. And with using RTI on papyrus, we will discover more about the technique of making papyrus, the technique of manufacturing technique of it. And if we have any written description, or sometimes they erase it and rewritten it again. So it's very good to study the reuse of this technique because sometimes we found a reused coffin, a reused papyrus, a reused object because in ancient Egyptian time.
Okay. Any other questions? I was curious about the spheres that I used. Are these easily available? The black spheres that I used, or are they specially made for this technique?
It's no, we can use any. Sometimes we at the beginning when we don't have this kit, we use the jewelry, it's fake jewelry that used by women. Some of them are like spheres, so we can use it. We just need a sphere,
A black
appropriate the
glossy
size.
surface,
Yes,
a spherical
yes,
glossy surface, yeah, that can
yes.
reflect the light.
Yeah, but the size have to be appropriate the size of the object.
Okay, the size has to be in accordance to the size of the object.
Yes,
So smaller objects will need smaller spheres, and
large object. Yes,
objects
we
bigger spheres. Okay, that's interesting. Any other question? Please type them quickly. No, I don't see. I think the presentation was clear. Our apologies for the audio quality. I think there was a little disturbance. A lot of people have said it's okay. So, thank you so much,
sorry. Yeah.
Mohamed Ibrahim, for that presentation. A very short, precise, and descriptive presentation on RTI. Thank you so much. Thank you, everyone, for
Thank
joining.
you.
Bye.